Hi everyone. So in this video, we'll be discussing regarding the next step after you load the data. The first step in any data analysis, we do the data cleaning and the preparation for the data analysis. Like we have the data now. Data is not always perfect. There are many issues with the data. There are some of the data is missing. Data is in correct format, right? There are some missing values, how to fill those values. There are some outliers, how to handle those, how to first identify the outliers. So we'll be discussing our data cleaning and preparation in the two videos. So this is the part one. So let's first go ahead and we are going to load our libraries in this import pandas np and import pandas pd and numpy as np. So let's first handle the missing data. So what do we mean by missing data? Let's first create this series. So in this series, we have five elements, right? And one is np.nan, means the value is not available. How to check if you have, let's say, some series, how to check whether the value is all the values are available or there are some nan included. So you can use is na, right? It will give you Boolean series as the output where false represent the it's not an NA and true represent this value is the NA. Let's create another series where we have included the null in the braces and NA in the brace. So here n null represent the value. It's not the actual null or the NA, right? And the np.nan and the none represent the actual missing value. So how to identify those? Again, we use the is NA function. So as you can see, in the case of 3, it's true. In the case of 5 is true, but in the case of 6 and 7, it's false because these are the actual values. It can be anything like null 1, so it's same thing. How do we filter out the missing values, right? So in this, before we do that, you can drop the values. You can drop the NA values using the drop NA function. So in this float NA series, I just include the drop NA, and as you can see, the values which are true in the previous one are dropped, right? And not NA is the negation of the is NA, so it will do the same thing. Uh, it will give you the extract of the values which are not NA. So this all the example were on the series. What about the data frames? So in the data frame, let's create a data frame of 4 rows and 3 columns, right? And if we do the data drop NA, what will happen? So it, as you can see, it dropped. If any value is available, any of the row that is one or more than one, it just dropped that particular row, right? You can see only the first zero index one remains, other have been dropped. So how how to include the values which have the NA. So you can use the how. What will do if all are the NAs, then only it's going to drop, else it will keep the. So in this case, the index value 2 has all the NAs function, but the others are uh, others have one or more values is available. That's why the value remain. So in the drop NA, you can use the argument how equals to all. Next one is let's create a data frame with the standard normal value from which has 7 rows and 3 columns, right? And let's create some NAs here. So what I'm doing here, till value 4 and in the column 1 make it NA, till value 2 in the column 3 make it NA, right? 4, 2, done. Now let's drop the NA. So what will happen in this case? We'll only get 4, 5, 6 because drop NA, if one NA is there, it just drop the full row. And we can also include the which is threshold of if it has two NAs, then only you drop it. Else keep it. Like in this case, 1, 0 and 1 has the two NAs. So threshold if it is meeting equals to 2, then it will drop. Else will just if it is less than 2, it is keeping the NAs values intact. Now we know how to identify the NAs and how to drop the NAs. What about if we want to fill the data? filling the missing value. So again, let's go to our data frame df, and I want to fill NA with 100. So in the case of all the NAs here, all the values will be 100. So you can put any value, so 1000. So all this will be updated with the values. Again, you can also pass a dictionary. So in this case, for column 1, it will update 0.5. For column 2, it will update with 6. Column up 1, it update with 0.5. Column 2, it updated with 6. Let's move to the next, create one more data frame of 6 by 3, right? And again, instead of doing the NAs in the top, let's do it the bottom, right? Start from 2. So this means start from 2 to till the end. In the column 1, start with 2 till the end with column 2. So we have the NAs. So we have also discussed these methods. This means forward filling, and this there is one more called backward filling. So what it does, if there are missing value and want to fill the previous value, you can use fill any method equals. So what the value is available here, it will just cascade it to the in this missing NA in this column. Similarly, this value will be filled. So as you can see, 0.2, it got cascaded to the end. It's got. So let's say you don't want to cascade to the till full all the rows in the column. What you can do, you can set a limit. Only two values will be filled. So in this case, there were two values filled, two values filled, two values remains. You can also take a mean. So mean is nothing. So df dot mean. So it just calculate the mean of these values, right? And whatever value is come, it just fill. If you are doing fill NA with the mean, it will fill with the mean. Next is data transformation. So let's how to remove the duplicate. So duplicate, you will get a lot of duplicate in your data. Mostly in most of the cases, there are some duplicate entries in your data observations. So let's create a data frame from the dictionary. So we have k1 and k2 are the two columns, and this is 1 2 multiplied by 3. So 7 entries, right? And again, this has the 7 entries. Now if this is our data, and we know this is a duplicate values are there, so which one is the duplicate value? This one is not a duplicate value, because these are two. Consider this as a tuple, right? 5 6 is a duplicate value. So if I do that and identify data to duplicate, so this one is the duplicate, means the duplicate of the previous value which is available in in this data frame. And you can use drop down duplicates. So in this case, the sixth row will be deleted. Index value 6. Let's add one more column v1. We are passing the range. It will give 0 to 6 values, and we can drop the duplicates considering one of the values. So in this case, if considering the subset k1, drop the duplicates. So what happened here? So it consider the only subset for k1, right? And as we can see in the k1, it's 1 2 1 2 1 2 1 2. So only the first value will remain, others are duplicate, because we are giving a subset. You can keep a two subset, like in this it will take us this tuple and then compare with the other values, right? Transforming data using the function or mapping. So let's create a data frame. So we have a food beacon, right? And the next was the ounces, and this is the data we created from the dictionary in a data frame format. And this is again one of the dictionary, if you meet two animal, from which animal the wheat is coming. So what we can do, we can create a new row, data.animal, which is not available right now, and on the data.food we can map this to this function, which is, what is this function do? For each element, what will happen, from food it will take bacon, goes here, it will check meat to animal bacon, meat to animal bacon, and the return value will be pig. So pig will be added into the animal. So let's first run this. Now this. So map is very heavily used in your data analysis map, apply map, right? Next is the replacing value. So replacing value is if there is some old value you want to replace, let's create one data series. So we can see this minus 99, minus 1000 is definitely not the correct value, and we want to replace this. So data dot series dot replace the old value and the new value. It will be replaced. Control Z here. Now, if you want to have a two values, you can make a list and then the new value to be updated. So this will be updated with the enhance. You can also create a input old values list, new value list, right? And also you can create a dictionary. Both will work. Renaming axis indices. So let's create a data frame. Here we have four columns, 1 to 4, and Ohio, Colorado, and New York as the index. And what we want to do, we want to make this in the uppercase. So again, data. What's happening here? It is data. Go to its index. Map means in index take each element one by one, give it to this function, so it will just update. So the output is all this value will be in upper cases, right? And as you can see, data is not being changed because the map function is not going to create an it's not going to change the original values, right? Similarly, if you want to update that, you can directly whatever value is available. So in this case, all this value will be updated into the data index, and then the value will be updated. So in case you want to update the, it will you can use a rename. So it's going to create a copy. It's not going to change your original data, as you can see like that. Discretization and the binning. So binning histogram, which we'll see in the visualization videos. What will binning do? Binning is, so let's create a two list. We have ages and the bins, and what we are going to do, we are going to use pd pen data frame dot cut. Cut is going to divide this ages into the category based on this bins, right? And interestingly, you will see its data type is category. It's a new data type, right? It converts all your data, in this case the ages, into the bins. Bins is means it's, let's say you have 100, you want to divide it into four, right? And that will be like 0 to 25, 25 to 50, 50 to 75, like so. And you can see what are the codes. So in this codes are nothing but these values, and the categories are, these are the categories. So it's 0, 1, 2, 3 categories. You can see that these three categories has been divided like this. So which category this codes belong to, you can see in this array. You can call, so as you can observe, here it is bracket start with the normal bracket and closes with the square bracket. So what this mean, the if the bracket is square, it's inclusive, means the value is considered in this bin, right? 25 is considered in this bin itself, right? And this means this is excluded, so 25 is not part of this bin. So that's what these brackets means. You can also add a group name, and in this PD cut ages be, and then assign instead of 0 1, you will be assigned the group, adult group, middle age, and the senior. So what I was mentioning, let's create a uniform of 20s, and we want to these divide these 20 values into the four bin, right? And precision is nothing but after decimal values. So these are the four intervals. You can see the codes. These are the codes which belong to 0 to 1 to 3, right? And these are the categories of uh, this particular value, right? Next one is, let's create the standard normals of 1000, and again we'll divide into 4% quartiles, 20%, and we can count those, right? How many values are there? So if you submit it's 100, so 439 belongs to this intervals, next to this interval 68 to these values, and minus 2 to these values. And you can also divide, instead of Python dividing your values, you can provide I need values in this intervals, and that's what it will calculate. Next one is the detecting and filtering outliers, very important. So let's say you are getting the observation of the ages and you see someone entering the ages instead of 3300. So that value will be the outlier, means the value is not related to what was the expected into the observation which you are collecting, right? So let's see we are creating a random norm from the standard normals 1000 into 4 matrix, and let's see what is this. So maximum value you can see this is more than 3 right here, and if you want to see data of 2, right? So let's do that, and what we are doing in the column we are making is absolute, so converting 0 minus value into the positive and checking if it is greater than 3. So we can see there are two values which are uh, greater than one value actually which is greater than 2, and let's select all the values and fetch from the data. If it is greater than true, check with during the column wise, and let's change the sign of it. So np sign dot data, what it will do -1 for negative values and 1 for positive values, right? And let's see describe. So as you can see, none of the value in the maximum is more than 3. It's either 3 or less than 3. So that's how you can control your identify. First identify your outliers and then change, do some analysis based on the values, what is your boundaries. Permutation and the random sampling, the last topic. So what will happen in this? So this is just let's create a one data frame. It has 0 to 6 values, and to create a sampler means permutation, it will generate 5 values, right, from 0 to 5. And what it will do, it will allow to fetch the data. So what we are passing data to take means it is according to this the index are being fetched. Of the index with the value 3 is fetched first, 1 2 like this. You can do with this with the iLock also same values, and also if you want to fetch the columns randomly, you can do using the first. Let's create column sampler and passing the data dot take column sampler these values, and now instead of on doing on the index we are doing on the columns, right? So 6 5 4 3 same order. Choice is another. Let's create a series with choice, and choice or sample means give me the 10 values and repeat it. If replace means repeat it true, right? Converting category variables into the dummy or indicator matrix. So this functionality will be more used in the machine learning and machine learning mostly any other statistical or data analysis part, where let's first create the data frame of key and values, and we want to convert these keys, right, ABC, into the dummy values or the indicator which highlights 0 or 1. Let's do that. So it the function where we are using get dummies on data keys on these keys and give the value output. So what it has done, it has created with this only with this column three values, right? There are three values A, B, C, and if value is 0 is B or B, so it is true. We can convert into 0, 1 using apply map. Now the values is more readable, right? 0, B is 1, like that. And we can prefix with the keys, right? There's nothing, just adding a prefix key underscore a, no much difference here, and joining with the actual this values. So this values dot join. So these were our values, and the key is now being transformed into the indicator matrix with 0 1. So let's take one example. So we have a movies uh, data set, right? Movies data set, and these are the first 10 movies, and you can see the genre is the animation children's comedy, and let's divide this genre into the indicator matrix into 0 and 1. So what I'm doing, I'm taking these movie genres, right? str get dummies means if pipe symbol is there before that, make it in dummies, right? Let's first check the top 10 rows and the top 6 columns, and I can join this with this, right? So the first movie was what? Toy Story, right? And it has the animation children comedy. As you can see, the animation children comedy is one, others are false. So it's just converting all your categorical or variables into the numerical way for the analysis. It will be very helpful to to run the statistics on the numerical values. So that's why we convert the categorical into the numericals. So that's it for now. We'll continue our conversation on this data cleaning with one more video. Thank you for now.